S1 Summer 2006 question 4 is binomial theorem. So the distribution is binomial. Number of trials is 10 for the number of saplings, and the probability of success, i.e. 1 growing, is 0.85. Then interested in the probability of 8, so that will be 10C8, 0.85 to the power 8, and then 1 minus 0.85, so 0.15 to the power 2. Typing that into the calculator, I get 0.2758, which to 3 significant figures is 0.276. Part 2 asks for at least 8, so that would be the probability of 8 plus the probability of 9 plus the probability of 10. So that's 10C8, 0.85 to the power 8, 0.15 squared, plus 10C9, 0.85 to the power 9, 0.15, plus 10C10, 0.85 to the power 10, multiplied by 0.15 to the power 0, which is 1, so I'm not going to write it in. Typing that into the calculator, I get 0.8201, which to 3 significant figures is 0.820. Part 3 then is at most 8, so that's the probability of none right up to the probability of 8. So we want to do 1 minus the probability of 10 minus the probability of 9. Quick way to do this is using our previous answers, and that would be 1, take away the answer to part 2 and add the answer to part 1. So we're taking away the values of 10, 9 and 8, and then we're adding 8 back in, and this gives us 0.4557, which to 3 significant figures is 0.456. Part 4, we still have a binomial, but we don't know how many plants have been planted. Probability of success is 0.85, but this time we know that the expectation of x is 13.6, and if we go to our formula booklet, we can see that that is n times p. So 13.6 has to equal n times 0.85. So if we do 13.6 divided by 0.85, we get that n is 16. Part 5 then, we're asked to work out the probability that exactly 1 does not reach maturity. Well, that means that 15 have. So that will be 16C15, 0.85 to the power 15, 0.15 to the power 1. And typing that into the calculator, we get 0.2096, which is 0.210 to 3 significant figures. In the mark scheme, we can see that they've used the column notation instead of NCR. You can use any notation for a binomial so long as it's valid.